In circuit theory, to determine the current, voltage, or power in any branches of network, we are going to use some of the theorems. In that, most important theorem is the Thevenin's theorem. And directly, I will go to how to use this theorem to solve any current, to determine the current or voltage. The following steps are used. The first step is determine the Thevenin's voltage, VTH, determine the Thevenin's impedance, ZTH. Then once we determine the VTH and ZTH, draw the Thevenin's equivalent circuit. Then for the Thevenin's equivalent circuit, connect the load impedance, determine the required parameters like current, voltage, or power across the load. Consider one example. This is a one simple network. Here it is for 10 volts and a 2 ohm, 4 ohm, 8 ohm. This is a load RL of 10 ohm. These are the 2 points A and B. For this network, find the Thevenin equivalent for the circuit shown in figure with respect to terminals EAB and also determine the current through load RL. Yeah. So first step is, step 1 is determine the open circuit voltage. Across these two terminals, remove this load, whatever the load it is connected. The first step is remove this load. Remove the load. When we remove this load, then determine the open circuit voltage across these 2 points, that is AB. So we have to find out the voltage potential difference between these 2 points AB. So now the potential drop across AB is also a potential drop across this 4 ohm resistor. Hence, we will determine the drop across this 4 ohm. Simply we can apply one KVL. The total resistance is 6. You call it as a current flowing in this loop as I1, 6I1 and minus 10 volts is equal to 0, or I1 is equal to 1.66 ampere. Once we determine this current, the drop across this 4 ohm is current into that resistance, that is a 6.66 volts. Next, second step. Once we determine this open circuit voltage or Thevenin voltage across these 2 points, next we have to determine the Thevenin's equivalent circuit. Looking at these 2 points AB, at these 2 points. If circuits contains any voltage source or current sources, if any voltage source is there, just simply short circuit it. If any current sources comes, we have to remove from the circuit. In this example, we have a 10 volt source. So just I will short circuit this. I have short circuited here. Now I am determining the impedance looking back here between these 2 points. When I am looking back here, then this 2 ohm and 4 ohm are, these two are parallel, and this 8 ohm is in series. So 8 plus 2 into 4, okay, divided by 2 plus, it is a 9.33. So for the given circuit, for this circuit, I determine the Thevenin voltage and also impedance looking from these 2 points. Now I will redraw the circuit. That is the third step. Thevenin voltage in series with the Z Thevenin 9.33 ohm. Next, connect this load RL of 10 ohm. When I connect this load, then ETH, this is the ETH and Z. The current flowing in this load RL is IL is equal to this E Thevenin divided by this plus this. That is the 9.33 plus 10 ohm. That is the 0.344 ampere. So in this way, we can use the Thevenin's theorem.